that the customer VIP, the monitor checks are false. You verify, okay, there is an error, but with the spec, etc., you verified. The monitor is not throwing the true errors, it is throwing the false errors.
Mm-hmm.
So you are like, oh, what I should do? Because y- whenever a company, give its code or package to some other company, it is always encrypted. You cannot see, you cannot go into their class and correct the correct the monitor or scoreboard or anything, whichever it is doing false. But
Yeah.
in UVM, you can do is you can on the fly, you know, disconnect their UVM monitor, but and add your UVM monitor. What I'm
Okay.
saying is this is encrypted package from some customer who provides a VIP. Their monitor is faulty. You have
Mm-hmm.
verified it.
Mm-hmm.
It's faulty. So what you can do is you can write your own monitor and on the fly you can disconnect their monitor and hook your monitor into their environment. This flexibility, for this much of flexibility, this UVM is majorly used.
Mm-hmm.
There may be chances there are multiple instances of monitor. And let's say you have a this VIP is able to connect to multiple protocols. So it may have monitor 0 and it may have monitor 1. Now you figured it out. Monitor 0 is working fine, but monitor 1 is faulty.
Mm-hmm.
So what you can do is based UVM also provides you this much flexibility. You keep one of the instance active but turn off another instance. And you can also hook to that particular instance your monitor also. See, I mean this is an advantage, na?
Mm-hmm.
Otherwise, if it would have been system Verilog, there will be no way. You are stuck and then just stuck. If
Okay.
something is faulty in some encrypted, because in encryption you cannot see anything. Encryption, whenever you go into the package you will see some random things like written in some kind of other language type. So something which you cannot read you cannot correct.
Mm-hmm.
Every company provides its encrypted package to protect its source code. Otherwise, if they will open the code to everyone,
Yeah.
then who is going to buy their license,
Yeah.
right?
Yeah.
So in UVM, this flexibility you always have. You can, even if you are not able to see anything, still you are able to override with the help of UVM. So that is the major flexibility. One thing is it provides you a general environment, or you can say constant environment, because you are following the same environment or test bench style. The customer, or you can say the from where you have taken the VIP, they are also following the same style of coding. So
Mm.
on terms of test bench style, you are on same page. It becomes easier for you to tell the problem to them also. You can easily communicate because of this standard style. So now let's go more in deeper in the factory overriding. So one thing is factory override. Factory means i- in the factory, um, the UVM has registered everything. So in UVM, factory has the ability to substitute a child class with another class of derived type when it is constructed. When it is constructed, what does this mean is in the build phase we create the it is UVM monitor. So now you can substitute UVM monitor with a UVM monitor only. It is not like you can substitute UVM scoreboard with UVM monitor.
Mm.
You need to respect their type. Then only you can able to override with your environment. This helps in changing the behavior of test bench by substituting one class for another without editing or recompiling the code. Without editing means you are not going to edit this one. You write this one and just hooked in their environment. Now with there are two types of overriding. You can override by type. Override by type means, for example, if in the VIP there are two monitor, so either you can override the monitor class itself. Type means you are overriding the type. Type means so both monitor will be overridden by your monitor or will be substituted by your monitor. And there is also instance override. Instance means if there are many instances, you can choose and pick to override which particular instance. For example, this is instance 0 and this is instance 1. So you can choose which instance you want to override. So here we have two types of overriding.
Okay.
Type override or instance override.
Sensor.
Type, yeah, used for overriding the type, like global override. And instance override is instancing a particular overriding a particular instance. So now let's see how you can override. In UVM, everything has a syntax, right?
Mm.
If you want to override by type, this is the syntax how you can override. So for in the first argument, you have to give the original type. What is the original type of the class? Then you have to give the substitute type of the class. And the third argument is, do you really want to replace or not? By default, it's one. However, you can choose in what environment. For example, you are running 100 of test case. And let's say you figured it out of 100 test case, only 10 cases are such in which UVM monitor is throwing false errors. So with the help of this particular bit, you can turn on or off only in those particular test cases where you find the monitor is faulty. So you do not have to write the whole monitor or so you can play
Mhm.
with the with this replacement. Similarly, there is the instance override. In the instance override, you will give the complete path of that particular instance. Complete path, what do I mean? In every test bench, the path is like test dot top dot environment dot agent dot monitor one. So this becomes my complete path of this becomes the instance I want to override.
Mhm.
In the agent, there could be multiple monitors. So I only want to override the monitor one. So like this, in the path, you will be providing the complete path to that particular instance. Then the type you will give, what is its type, and then you will provide the substitute type with what you want to replace, and then the fourth argument is replacement. So instance override is also like type override. It's just it has one more argument, that is the complete path.
Path.
Okay. Now, original type is the name of component that has to be replaced. Name of the component. Substitute type is the name of the component by which original class has to be replaced. Path refers to hierarchical position of the component, and replace specify whether to replace definition in factory or not. Because every time you may not want to override, but in some cases you want. So this helps the factory to manage when to override and when to not.
Mhm.
Now let's see we have the simple test bench environment. We have a test. Inside the test we have environment. Inside the environment we have two agent for the UART. And inside the U agent, each agent has its driver, monitor, sequencer. Similarly, this has driver, monitor, and the sequencer. So what you can do is, this is simple. This is environment. in the build phase. So now just to, remember this thing. You can only override prior to creating. Once something has been created, you cannot substitute it. So always and always, this set override and instance override happen in the build phase.
Okay.
Always. If you do after the build phase in any other phase, let's say you have written this particular line inside the run phase or maybe connect phase, then you will not see the significance.
Mhm.
So prior to creating, you have to, override so that UVM knows, you factory knows, okay, this has been created and I have to override it with this. So simply you can, override like this. In this particular environment, it has, replaced the agent of UART with SPI agent. So it was the um,
Agent.
original, no, not agent,
Uh,
UART. Yeah, it has replaced the agent because UART is the
okay.
UART. First argument is original type. Here, UART, original type, and now it has replaced with SPI. So now the same environment, this UART agent has been disconnected, and now in this particular environment, the SPI agent is connected now.
Okay. So you SPI is a means.
Separate, you can say a separate, because the SPI agent will also have their driver monitor sequencer. So now
Yeah.
the connection has been broken from here.
Mm.
Earlier in the environment, everything was related to UART. Now in the environment, everything will be related to SPI.
Mhm.
Now result. This becomes your result. If you see, because we have done it by type override.
Okay.
So now this was the original. Now it become this. Now it become the SPI agent.
Mhm.
What if you have done it with instance type? Let's say you want,
So suppose if we are only changing the driver, it is instance.
or you can say uh, in the agent also. If you
Only one agent.
agent,
If you
yeah.
have. Okay.
So then your environment would be like this will be UART and the another instant would be of SPI.
Mhm. Okay.
Similarly, you can also do for the driver monitor any class. You
Mhm.
can do. It is not only limited to agent or any class.
Okay.
Any object, any component, any interface, anything
Mhm.
registered in the UVM factory, you can
Okay.
perform this thing.
Only one specific component, then it's instance. If it is not specified, it will change.
Type, yeah, you just change the type.
Mm.
So how this will be done? Now question is this. Okay, I write this particular line, I got it. But let's go into more detail. So in the everything in the UVM, everything has been maintained in a database. In a database.
Mhm.
So database like it has database. In the database, it knows it have a test, it have a environment. Inside the environments, there are some other classes, some other components. So it has maintained a complete dat, data set.
Mhm.
So we we can either set something, uh, and one more thing. With the TLM FIFO, you have seen the connections, uh, setting, I mean, For the communication, we have used TLM ports, right?
Mm, mm,
For the TLM ports, it become necessary to do the to do the connections. Without the
mm.
connection, can you get or set any packet in the environment?
No.
No. Now here comes one more concept of the UVM config. Now let's say this is your environment. From environment, you want to set something. Set something means setting some configuration.
Mm,
Configuration means, let's say you have a packet which has which has some um, s- which has some fields like um, just I'm trying to remember anything.
For example, in my project, uh, if I was supposed to
Mhm.
send a 4K video, I'll set the resolution from the
Yes,
test.
yes, yes. We can set the resolution. We can send resolution. We can send the data width of that particular thing. We can set the, you know, we can set some address width.
Mm,
There are possibilities like up to this environment, the resolution is 4K, data width is let's say 1K, and
mhm,
address width is 2K
mhm,
for this particular environment. But in this particular environment, the same thing is different. Let's say it is 8K, 2K, 4K.
mhm,
So there are one way to communicate this thing. Either you create so many TLM, uh, uh, declare some TLM transactions, and then every time from the test or some other class, every time send, right?
mm.
Another way could be you just set the configuration here. And in every agent, depending upon its type or something, they will get automatically. Get means set it here, no connections required, no connections, nothing.
Okay.
Just set it in the factory. That set it like yeah, in the test, I have set some class. Let's say this is my configuration packet 1. Okay. Configuration packet 1, and with the help of some arguments, I have set it for UART. I have set another packet configuration 2.
Mhm,
Configuration 2 that is for the SPI. Okay.
mhm,
Now in the agent or any of the class which are extended from the UART, you write some method or you write something to get. Here you will be from one place you will be setting, and in another place you will be getting. In this type of get set thing, you do not need any kind of connection. No connections required.
okay.
No connection. Now, how? Because earlier we have seen it was possible because of the connections only. But now you are saying without the connections, I can do this thing. Question arise how? Now
Yeah.
the answer lies in the UVM config DB. This UVM configuration database, it is just like a database. So there is some database. If you are an agent, go and look into the database. What is the configuration? I have set it based on the protocol. Now it's your responsibility. Go and see. Go and see. See means I have only set. Now you can see you go to the database and see what is the configuration.
Mhm,
Now let's see how. UVM provides configuration database class to set integer, strings, virtual interface, objects, etc. Resources with hierarchical context. Hierarchical means when it is setting the configuration one, it sets based on the hierarchy. Hierarchy means I am setting from the test, then top, then maybe in the agent. I am setting in the agent. Similarly, for the SPI, I may be setting from the agent 2. So you can set the config database with hierarchical context. All functions in the UVM config DB, this is the database. This is the class which is containing all the database. This is a class.
Okay.
And this is the instance name of that particular database which is there in the UVM is maintaining.
Mm-hmm.
Inside the database, you provide the type for which type you want to see and you can access it. So these UVM config DB are static in nature and can be accessed with the help of resolution operator. If you
Okay.
try to relate it, this is also system verilog. We have some class or you can say package and we are accessing the fields with the help of resolution operator only.
Mm.
In a simple environment, or let me see if that particular calculator project. Yeah, yeah. If you see, this is a complete environment of a some test bench. Okay, some test bench. Where is it? Stop. In this particular example, the only virtual interface has been set. So yeah, yeah. In the top class, this there is a virtual interface which all the component needs to get. You cannot send the virtual interface with the help of TLM ports, right? You can send only the packet type of things you can send from the with the help of TLM ports. You can send the classes type with the help of TLM ports only. But there are also many other things which one class may need to access. So from some of the top class, you can set certain things with the help of UVM config DB. Now let's see. In the UVM config DB, the first argument you provide what is the type you want to set. Hello? Are you in the class?
I can hear it.
So with the help of config DB, first argument will be what is the type you want to set. And then
Mm.
resolution operator, you will call its set function. In the set function, there will be certain arguments which you will add to provide the context to the that particular uh, thing which you are setting. So
Mm.
with the help of these argument, you are providing some you are providing, for example, you are living in some place. So the some place will be like India. Inside the India, there will be some state, let's say UP. Inside the UP, some city, Noida. Inside the Noida, there may be some sector. Okay, let's say sector 35. Inside the sector 35, there will be the name, address of your home, right? So these
Mm.
four arguments provide the complete, you can say reference point to which, because in a factory, there could be virtual interface 1, virtual interface 2, class object 1, object 2, or packet 1, packet 2. There could be so many things. So how you are going to identify which is you are referring? So these four arguments will provide you the context to access something. Because earlier what I said, with the help of set, they will just set. Now it is your responsibility to go and see. Now how you You will go, and how you will see? Only when you have the full reference, you can say, to which you want to access, right? So these four parameters will provide you the reference.
Okay.
From one point you will be setting, and from other classes you will be getting like this was our setting. Now I'm writing it here. So now let's see. In the driver class, it is similarly to the set, it is using the get function. From one place this has been set, and in other class where you want to access this, you will be using the get function. Get.
Mhm.
If you see, it has some arguments. Now it is also providing the arguments to access only this particular one. Okay.
Yeah.
Similarly, in other class also, here you see again with the, so at one place you will be setting the configuration, and another place you will be getting the configuration.
So it is written in the design file
Mhm.
setting.
Mm.
So it is we think we can access is the interface only, right?
No,
So we are writing.
this has to be defined. For example, you want to access, mm, uh, here I've just copied it, but it is in the top class of the test bench. And even if it is in the design, so you need to know the arguments which you can, pass to, set or get the things. These
Mhm.
four arguments will help you to, because for example, let's say this design unit, and this is also encrypted for you. Okay. And just suppose, someone has also set something inside their design unit using the config DB, and you want to access it. So you can also access that as far as you know how to reference that particular, uh, I mean, how to reference that particular thing which they have set. And has they opened the visibility to you also or not? That can also
Mhm.
be governed with the help of these arguments. These argument, for example, we have some environment. Inside the environment, we have some env, and inside the env, let's say we have some agent. Now let's suppose test is setting some configuration, but with the help of these four arguments, it has disabled the visibility to this agent, to this environment. With the help of these arguments, it has said something like it will only be visible from agent to any below the classes. It can choose, with the help of these four arguments, we can enable or disable the visibility to what
Mhm.
classes can access it.
Yeah.
And similarly to the get, there will be a similar function to the for the get also. First we will set, and at other places we will get. For these set get thing, you do not need any kind of connection. It
Mhm.
just, the class should have the access to that particular object. Access means the arguments should be set such that it is visible to that class. As far as that thing is visible to you in the configuration, you can get it.
Mhm.
Okay. First, let's see the arguments in the detail, then it will be, more clear.
Okay.
First and foremost more rule. You just understand from one place we will be setting, and in other places we will be getting using the
Get.
get function. Now let's see the arguments of the set and the get. So this has four arguments. Four arguments mean first argument will be the context. This argument will be the type what you are setting, because the factory needs to know what are you setting.
Mhm.
These four will be the reference point, because you may set like in this particular example we may have set, let's say in our environment we have 10 different kind of interface UART, and let's say I have set it UART. We could have more environment interface UART. So here we have two interfaces. So in the type you just set, I am setting the UART interface, and with the null of and with the four arguments you are providing, because there may be more interface of the UART. So with the help of these, let's say this is your instance 2 of another UART interface. They are of same type, but the instance are different. So you, with the help of these four arguments, you can set a lot of things. But while
Mhm.
getting, you should be clear what you are getting.
Okay.
These four arguments will help. So in the first argument, we will provide the type. Type is used to specify which type of field. Then there is context. Context is a prefix added to instance name. Here we will be providing the instance name of
Mhm.
that particular thing which we are setting. If null, then in your environment also, and for most of the time, you will see while setting the null here. Null. Why people set it null? Null means nothing. So when you set it something to null, it is visible from the top.
Okay.
The top means even if I have set it inside the agent, but in the context I have set null. So then the test class can also see that particular configuration
Okay.
visibility.
Mhm.
So this other another word you will be seeing here in the set, this keyword. If you use this, so then the age classes below the agent only can see.
Okay.
Null makes the visibility to all the classes, and agent this makes the visibility to the children classes only, children or grandchildren.
Mhm.
So this context specifies from where you want to set. Then there is instance name. Instance name is like here. Here we are providing, most of the time you will see star. Have you ever seen any of the scripting language or GVM, anything?
Yeah.
So star or wildcard stands for what?
Select all. Like that.
Anything.
Yeah.
Correct.
Yeah.
I am providing null and then star. What the, from layman language, what you kind of interpret?
Well, within that, all the files above and below can anything
Yes,
can
yes,
access.
anything, any file can access.
Mm.
With the null and the wildcard star, any file above, below, doesn't matter,
Mhm.
can
Mhm.
have the visibility to this particular instance.
Mhm.
So they first two arguments are the most important argument which affects your visibility to the other classes.
Mm.
The first const, if null is, if you set it null, then your instance name will provide the complete scope of setting. And in the instance name also you provided what? Wildcard.
Mm.
Wildcard means, oh, everyone see,
Mhm.
doesn't matter. But
Yeah.
You provide some instance name. Instance name is like, you can do it like this also. In the instance, let's say mem, or you can say agent, or you can say agent 0
Mm-hmm.
star. Now it will only be visible to the agent. There will be, can be multiple agent. So
Mm-hmm.
this particular instance will be only visible to the agent 0, zeroth instance of that particular agent.
Mm-hmm.
And then star. Star means, above anything. Because the names, how the names are like? The names are like this. So anything after the agent 0, this particular whatever you are setting will be visible to from agent 0.
Okay. So is it dot star is required? Huh?
Not dot star, it's star.
Okay.
So instance name is the place from which setting. So if you provide it null, then
Mm-hmm.
instance name provides the complete scope. However, this null and this context and instance name itself, the combination of them provides the complete scope for the this. Then another is field name. Field name, you will give a name to the instance. Instance means, for example, you go in a school, you just do not call child, child, child. There are names to the child,
Yeah.
Akash or any name. So you also provide the name to that particular instance, because in the
Mm-hmm.
same hierarchy there could be multiple objects in the that particular hierarchy. So which instance you want to, or you can say which particular uh, instance you want to access. So then the
Mm-hmm.
third argument will, you will give the instance name to it.
Mm-hmm.
Place from which field name is the name of the parameter which you want to access. And then value. What value you want to give?
Okay.
The value is simple value. Okay.
Yeah.
Now similarly set, we will have the get.
Mm-hmm.
So you need to be aware about the context and the instance name like this. Uh, it also has the context, instance name, field name, and value.
Okay.
You have set it something like this. You have used this in the context, then agent. So this refers to what? In system Verilog, this refers to what?
The current class.
The current class. So from the current class, your scope will be visible. For example, you are this is you are setting in the environment. Let's say environment, and you give agent 1. So even if you are setting from the environment, the things will be visible to what? Agent 1,
Mm-hmm.
not to the agent 2.
Okay. Mm-hmm.
This means we are setting from here, and this will also block the test to get the visibility.
Mm-hmm.
This means current.
Yeah.
Current, then you provide what? Star. Wildcard means from this particular class, like this. If you have set, and let's say there is one more class in between, some wrapper, let's say.
Mm-hmm.
Okay. Wrapper 1 dot. So what this will make it, and now let's say you are setting in the env. So now this is allowing how? From env star
Mm-hmm.
star to agent 1, and then this dot is for the hierarchical. Do not
Mm-hmm.
consider it as like dot star like the GVM. Here only the
Mm-hmm.
wildcard, focus on the wildcard only.
Okay.
Okay. Agent 1 dot. So now it will see, and then again star. Now let's say it has a lot of classes, then it could have 2, and then agent 1 scoreboard, let's say. and let's say scoreboard 2. So now out of these four things, it will be visible to whom?
Second one.
Yes, second one only. Though the agent 0 is inside the ENV, but still it will not be visible to
Mm-hmm.
agent 0 things.
Mm.
What if I do it like this? Wrapper, wrapper. Then from environment, it will be visible to all.
Mm.
I can limit the wrapper also with the help of this. So this provides you, how you want to traverse.
Mm-hmm.
What if I give this and then star only? If my arguments are such this, then how?
From E from ENB to everything.
Yes,
No,
from
only
yeah, from ENV to everything.
mm.
All these, all, all of the path will be um, come into its context. Now it has provided given some name is active, and then you can set the value. So
Yeah, field and value.
yes, field and value. So the um, last two are comparatively simple. The first two are comparatively, difficult to understand in first go.
Mm-hmm. And that void is return type is here void. Na?
Yeah.
So
While
uh,
setting, there is no need to provide the type. This is
okay,
the set. But while getting, so you need to know the result. Have I get or not?
but here type bit is written. Na? Uh,
Here we are setting. What we are setting? It is
no,
referring
in
for this.
get also bit is written.
Just forget about this void as of now.
Okay,
Just
okay.
for the sake of, simplicity. I will come to it.
Mhm. And one more thing in that, what is assert there in the top first line of the slide?
This is for the because it is going to return something. That is why. Here also that is why void is used.
Okay.
Because while setting, you just set. But while
Mhm.
get, you need to know the result. Have I get or not? How you are going to know? If you are able, for example, there is the database, and let's say you are not able to, what if I have set it like this? Will you get anything? If in the set I
No,
did
no,
like this?
no,
No.
no.
So this would have result you what? Error. Because you may be f- on further go, because why are you getting? Because you have the need for this particular
Mm.
object. But if you do not get, your whole complete code can burst.
Yeah.
So that's why while getting, we need to know the status. Are we able to get it or not? So that's why the get argument returns the value. Either
Mm-hmm.
it's 0 or 1. 0 or 1. So that's why this whole particular get thing returns. If it is successfully able to get, it returns 1.
Mm-hmm.
Is not able to get, then it returns 0. So that's why they have done the casting with the void. Just ignore
Mm-hmm.
whatever we are. And here in the assert, if the answer is 1, no issue. But if the answer is 0, error, throw the error. Because I need it. I need the configuration. Without the configuration, how can I proceed?
Okay.
So while setting, because you can set thousands of the things,
Mm-hmm.
but while getting, it becomes a matter of concern that I need to get the thing.
Mm.
So that's why on the setting you have seen nothing. but on the this get function gives you either 0 or 1. So that's
mm,
why your environment also, if you go into your office environment, you will see the set is simple, while in the get it is always inside if. Agent, the driver, yeah. See, in the driver, if it is
mhm.
not able to get, then throw the UVM error, unable to access the interface.
Okay.
Okay,
Yeah.
because it would have written 0 if it was a unsuccessful. Then not of 0 becomes 1. So then throw the error if it is a 0, if it returns a 0.
Mm,
Either you will see UVM error or you will see UVM fatal. Okay. So with the help of set and the get, we can see the configuration in the database.
mm,
Now, let's see the this whole particular example again. We have one agent class. In the agent class, in the build phase, we will be setting and try to keep the settings either in the top and if you are setting in the classes, always set in the build phase. In the build. Why?
mhm,
Because the build phase will be run earlier than other phases. So it if you write in the build phase only, it provides you the surety that okay. Otherwise, there may be classes that are build, but then you are setting. So there are chances that the other class may have not get it, even you have set it properly. So always and always try to write in your set things in the build phase.
mhm.
Okay.
Yeah.
So now you have set something as is active, some variable as active 0 and 1 for the agent. You have created the agent. You have set it prior creating to the agent so that when the agent gets its memory and try to get this, it will not see a null object access because what I could have done this and inside the agent, for example, inside the agent class and in the build phase, I am getting this, but this has created
Before.
before and it is setting later on. So in the build phase of the agent, it will throw the error. I do not see any is active. I do not see is I do not see any is active. So it becomes necessary. So prior building, you just set everything so that the things are aligned. Okay. So it has provided the null and then this wildcard and then it is setting like this. So one agent. Now let's see environment. Now agent class. Simple agent class has three different things. Now it has a bit active. Now inside the build phase, simple build phase. Now super dot build phase. Now it is trying to get what I am active or not bit. Then this in this particular class here either you can provide something like argument or you may choose to left it blank. Left it blank. Why? Because here you have so many things. So UVM has an inbuilt capacity to map the things properly.
Mhm.
But you have, if you have, because you have name also. But if with the same name, there are, where is that? Let's say I have set it like is active 0 like this. Mm, env star, and I may have set same. So now you see the, or let's keep it confusing only. If without the this, and this agent will try to get, it will get confused. Which active? I am seeing two things. If you have set it like this, the agent will get confused because in the first two arguments you are providing nothing. You are providing
Mm,
only the is active.
mhm.
And with the is active, you are seeing two variables. Just,
Okay.
just a minute. I have some. So now your agent will get confused. Which active? I am seeing two is active in the same context, etc. So that's why it becomes necessary to provide the context also. But
Okay.
if you know you have only is active this, you are only setting one variable. So then even if you have not set it, you have not provided any context, it will still be able to get is active. I hope I'm making some sense.
Yeah, but
There is only
this.
one thing. If there is
Mm,
only one thing, you can skip
mm,
writing all the, providing the full scope. But with the same name also, you are setting multiple things. Then do
mm,
provide the context. What I'm saying
mhm,
this.
mhm.
Okay.
Yeah.
So now it has get the is active. Now if is active equal to 1, it is creating the driver and the sequencer. But if it gets is active 0, then it is only creating the monitor.
Mhm,
So most of the time in UVM, you will see majorly two things: setting and getting with the config DB. That is, one is the object configuration class, because every component, each component needs to know on what configuration I'm running. And another thing is because in the class you cannot directly use the interfaces. In the system verilog also we have discussed this thing, because interface are hardware thing and classes are
gotcha.
virtual things. So to access the interface inside the classes, we use the virtual interface.
Mhm,
So when we did the APB project, we manually did all the connections. All the connections, like, if I have the code, let me see. APB. Is that code? Here it was our APB project. If you see in the APB project, in all the new interface we have, passed on the interface. And in the top, this was our top class. Inside the top class, we have manually passed the interface to each and every class,
mm,
what all were using. Now let's say if the number of the classes would be 100, which are using the configuration. So manually, otherwise, if this get set thing will not be there, we will be manually passing all the interfaces or all the virtual interfaces. But this provided us flexibility that in the top class, you set the interface, and in another class, you simply get the interface like this.
Okay.
So at one place, we are setting, and other place, we are getting based on these three arguments.
Mm-hmm.
Other, so now there is no need to connect everything manually. No need.
Mm-hmm. Mm-hmm.
Simply, if you want to use it, get it and just play with it.
Okay.
So, so most of the things which, as I was telling earlier, you will be setting either the configuration packets or the virtual interfaces. You will be seeing most
Mm-hmm.
setting and getting with the help of this config DB.
Okay. Configuration packets and
Virtual
configuration
interfaces.
packets, it will be mostly from test.
Yes, from test.
Uh, okay. These interfaces will set in the interface and connect to the components. Get it from the components.
Yes, get it in the components.
Mm.
So with the four arguments, you will be setting if your environment has, doesn't matter if your environment has 100 instances or 200 instances. As far as you are rightly using these four arguments, you will be
Mm-hmm.
able to get set things properly.
Mm-hmm.
Okay.
Okay.
In the agent, we will be getting. If the we are not able, if the class is not able to get, then throw the UVM fatal. Otherwise,
Mm-hmm.
there is no purpose of driver. Now, what driver will do
Mm-hmm. Mm-hmm.
or what other class will do? So similarly, while getting, you will see something like this always. If it is unsuccessful, in most of the cases, you will see either the UVM error or UVM fatal.
Okay.
Inside the build phase, you will be getting the uh, your int. Now, for example, you have set many things, but let's say you are still not able to get the virtual interface, and now you have to debug it because everything is going inside the UVM, right?
Mm.
So debugging becomes a lot of times tricky. Tricky means I, I mean, though I have set it properly, but still I'm not able to get. Then what to do? So then to the rescue comes your resource DB. Most of the things have been deprecated. People do not use resource DB at all. But
Mm-hmm.
for one particular thing, you can use it to see uh, for the debug purpose only.
Okay.
This resource DB is also like config DB, but
Mm-hmm.
you're mostly using the config DB instead of resource DB. But still, there is one place. Let me tell you, in the if in your environment anywhere you call the dump. Let's say, let me add in. Let's see here. So whenever you are playing around with UVM config DB and get stuck in it, so always use this hash. I want to see the dump of virtual interface. This will dump all the things. Where is the compilation? Have I did anything wrong? Have I did anything? Oh, what? Yeah,
Showing some syntax error.
yeah.
Config
Well,
DB.
actually, I added some of the string, so that's why. Env, yeah, driver. Is this getting not? So let's say. there is some problem and you are getting this particular error. So prior to that error, what you can use is UVM resource DB, provide the type, and then dump. So this one dump will be the most useful, uh, method you will be using. Is not defined in, maybe it is like this. It prints like this resource pool that you have set some virtual interface. It will provide, like here in the bracket, it will provide from what you have set, and this is from TB to VIF, if I tell you. So if any time you are not able to get, you can use this resource DB and see what all the things you have set it. Because this is a very simple test bench. It only has one, but in an actual environment or when you work in some company, there are like thousands of things which we set. So there it gives a long, long, long list of pools. Resource pool
Um,
and then end of resource pool.
what it actually prints? I didn't get.
It will print all the things with the, where is it? Yeah, it will print all the virtual interface instances it have in the type, if you provide
Mm-hmm.
the type. If you don't
Mm-hmm.
provide the type, it will print everything. Or I have to give, for what type I want to see. Just try to use this particular thing in your environment and then see,
Mm-hmm.
what,
Mm-hmm.
because I do not have a very complex environment where I can show you the utility.
Okay.
But if you use it anywhere in your test bench prior to getting, you will see a lot of things which have been set
Mm-hmm.
with the configuration DB.
Mm-hmm.
You will get a thousands of list, thousands of things which have been set.
Okay.
And in the, and this, or let's say if something, resource DB dump prints. You can also use the config DB dump also. Mm. Because a lot of time, people want to see, what has all has things have been set using the config DB. Because so many times the problem is I get the wrong packet, the configuration is set wrong, the test case is run, but the configuration it get was wrong. So a lot of time people went into those kind of problem also.
Mm-hmm.
I don't think so it has.